Section 11.8 Power Series. What is a power series? We have discussed or looked at many series right now. So it is something which looks like this. Summation n is equal to 0 to infinity. Now n can start at 0 or any other number. So and inside the summation we have Cn x to the n. So what is this Cn? It could be again anything. It's designated as the coefficients of the terms of the series. So if you notice, this is like a polynomial. If you recall a polynomial, linear polynomial, we can write it as a sub 0 plus a sub 1x. Now usually we write it as a x plus b, but you know we can write it a0 and a1. And if we write the second degree polynomial, it can be a0 plus a1x plus a2x square. This is the quadratic polynomial, and in the same way, if I add one more term, it becomes the cubic polynomial and so on. But in this case, so if I have up till here, this is a polynomial of degree n. But note here in the series we have a plus sign here, and it keeps on going on and on forever. So which means we have a infinite polynomial. Now given a series, actually if you notice what is the difference between this power series compared to the other series that we have seen, that there is an x in this power series. So what is the effect of the x? Well, the divergence or the convergence of the series will now depend on x. In the previous, it depended on the n. So, because we didn't have an x in there. But all the other information about series will stick to this power series as well. Now, so as I said, the convergence and divergence will depend on x. So the different values of x for which the series converge or for which the series diverge, that is what we will try to figure out. So consider the power series. So I have a power series over here, 1 over n factorial times x to the n. Now notice here, we have seen this without the x here. This series we have seen, okay, we might have seen that. So you have to check whether it is convergent or not convergent. You can easily do that by using some tests you have learned. But now we have x in there as well. So now to check the convergence and divergence, we will see in a few minutes, but first let's expand and see what are we getting. So we are getting, if you expand, so the first value is 0, so 1 over 0 factorial times x to the 0 plus 1 over 1 factorial times x to the 1 plus so on so on. So we are getting terms like 1 plus x square over 2 plus x cube over 6 plus x4 over 24 and so on. Now how do we evaluate? Well, for x is equal to 1, what will be the series? So you will plug in 1 in here and you get summation 1 over n factorial. If you plug in x is equal to -1, you get -1 to the n, because x is -1. So you are, in place of x, you are getting -1. So -1 to the n over n factorial. That's what we have here. And if I plug in x is equal to 2, I'll get x summation 2 to the n over n factorial. We can now check the convergence of these series by the rules we have learned. For example, I have written here that this series summation 1 over n factorial, this converges by ratio test. So what was the ratio test? Remember here an is this. So we have to do limit of an plus 1 over an So I have to do limit an plus 1 for an, and then absolute as n goes to infinity will be equal to limit n goes to infinity of what, 1 over n plus 1 factorial divided by 1 over n factorial, so which will be n factorial over 1. So you can see that we will end up getting limit n goes to infinity 1 over n plus 1, and then that is 0. So this is less than 1, so converges by ratio test. Now for the next one, converges by absolute convergence test. If you recall, the absolute convergence test is kind of similar to the ratio test. We can actually do it with the ratio test as well, but the thing is, absolute convergence test, we are checking just this thing, so we are basically getting the same thing as we have here. So that converges, so it means this also converges. But the first case with x is equal to 1 is the case of the absolute of this series. Next is 2 to the n over n factorial. So the same thing as ratio test. I'll let you guys do it yourself and check that it converges. Now, a power series about a, so about a number or just the power series, the generally we have the power series written like this. There is some coefficient times x minus a to the n, where a is some fixed number or fixed point. So here a is the a and the cn's are numbers and x is the variable. Okay, some things are missing in this sentence. The cn's are often called the coefficients of the series. Now we notice here, I mentioned before that x is in this series is a power series is a function of x. So if you notice, we have an x introduced into the series, so it becomes a function of x, so we can write it like this as a function. Now for which values of x will the series converge? This is our question. Whenever we have series, we want to see where does it converge and where does it diverge. So asking where for which x the series will converge is basically the same thing as finding the domain of the function, which is the series. Now again, a power series may converge for some values of x and not for other values of x. But if we have x is equal to a, number a is this fixed number, then what do we get? What happens then? So if you look, I mean, like, this might be like intuition, or the first thing to come to mind is just plug in a for x here, so everything is 0, so we get 0. No, that's not true, because we first have to see where x is coming and then we should plug in x is equal to a. So if we expand the series, because it's starting at 0, so the first term is just c sub 0, because x minus a raised to the power 0, so it will make it 1. So it will be c naught plus c1x minus a plus c2x minus a square, and so on. So c naught doesn't have any x value, so all these x values will become 0, so we have just c naught left. What does that tell you? Well, we are getting a specific number, or a number here at the end. When I add up all this in terms of the series, it means this converges. So this tells us that no matter what the series is, in the power series is, it is always going to converge at the a. What is a? That is the constant term in x minus a in the series. In general, we will be able to find a number, we call it big R, such that the power series will converge when x minus a absolute value is less than r, and if x minus a absolute is greater than r. So what does this tell us actually? If you recall um, from your algebra, this can be split into inequalities like this: minus r is less than x minus a is less than r. So add a to both sides in all three parts. So here we get a minus r is less than x is less than a plus r. What does that mean? It means when the x is between an interval negative r to r. Okay. So, and over here, yeah, so that's what I said. The interval negative having the radius the radius will be r. Where by radius I mean the middle of the half of the interval. So power series converges when x is in here, and then we have it will diverge when it is outside that interval. I will show you the picture in a minute. Now so notice here the interval we have here is open. Open means the endpoints are not included in here. So what happens at the endpoints? So that is something that we will check individually or separately. So the interval including all the endpoints or not, depending on the convergence and or divergence at the endpoints. So that will be called the interval of convergence of the series. And this value r is called the radius of the convergence. We already saw that. So in order to find the convergence or divergence of a power series, always start. Here are the kind of the steps that you have to follow. The first is that always start with the ratio test. What is the ratio test? That you find the limit as n goes to infinity of a n plus 1 over a n absolute value, and let's call that limit L. Now if L is less than 1, we say series diverges, and if L is greater than 1, when L is less than 1, it will converges if L is less than 1, diverges if L is greater than 0, and inconclusive if L is equal to 1. So endpoints are tested separately. Now this is what we were talking about up here, that the interval of convergence is always one of the following. What? That convergence is happening only at A. That can happen, that the series converges only at the A one point, and in that case we say the radius of convergence will be 0. So r, value of r, so this is r. Second row is representing r. Now it can happen that the interval of convergence is negative infinity to infinity, means the whole real line. In that case the radius will be infinite. So r will be infinity. If you have restricted interval of convergence, something like this, between 2 points, then r is whatever we are getting over here, the r. Now in the rest of the cases it's going to be the radius is going to be r all the time. But in the case of the convergence, you can have these 4 different scenarios. One is that it converges in the interval and the endpoints are not, both endpoints are not included. Second case is we have the interval, then we have the left endpoint, because if you notice on the left hand point there is a square bracket. So square bracket means that endpoint is included in the set or included in the interval. On the right hand side we have a parentheses, which means endpoint is not included. In the third case, we have parentheses on the left and a square bracket at the right, which means right endpoint is included but not the left endpoint. And the last one is on both sides we have the square bracket. It means both endpoints are included in the convergence interval of convergence. So now let us look at examples. So first one, we have to determine the convergence and interval of radius of convergence and interval of convergence of the series. Okay, so this is how we start. Remember, the first step is to use the ratio test. So here you can see our AN is times x plus 2 raised to the power n. So what will be AN plus 1? AN plus 1 will be negative 1 to the n plus 2 divided by n plus 1 whole square times x plus 2 raised to the n plus 1. Okay, so now let's say L equals limit as n goes to infinity of an over an plus 1 over an. Okay, let me write it, and absolute value. So this will be equal to limit n goes to infinity of absolute value. Now remember, when you have a fraction over a fraction, this is going to be a fraction over a fraction case. What happens? The first fraction you write as it is. So I will have negative 1 raised to the n plus 2 times x plus 2 raised to n plus 1 whole thing divided by n plus 1 whole square times, now the second fraction will be inverted, so the n square will come on the top, and over here I have negative 1 to the n plus 1 into x plus 2 raised to n. Okay, simplify this. What will happen, you should be able to see that here we have x plus 2 whole raised to n plus 1, and here we have x plus 2 whole raised to n. So this will give us just x plus 2 raised to 1, which is just x plus 2. The negative 1 over here is n plus 2 and n plus 1. So we end up getting, this is equal to, let me write here, limit n goes to infinity, absolute value. So for the negative 1, I just get negative 1, and then x plus 2 at the top, and then I have n square over n plus 1 whole square, which is equal to limit n goes to infinity. Now notice here that we have the negative sign would go away, and the limit is going to be on n square over 1 plus n plus 1 whole square, and that can be pulled out of the absolute if you want, or we can take the limit inside, but the absolute, because n is not going to be negative, so this term is not going to be negative, so we can pull it out of the absolute value sign. You don't have to, but you can. So we have limit of this times. Now remember, we cannot just throw away the absolute sign. will still stay on the x, the quantity which has x in it. Why? Because we don't know about the variation of x. So this is going to be now limit. You should be able to see that we have a quadratic over a quadratic, and you may expand it. So n square over n square plus 2n plus 1. And then we have absolute sign of x plus 2. This is what is it. But this limit is 1. So we end up getting the absolute value of x plus 2. This is what we are left with. Now if you go back and look at what the ratio test tells us, it says when L, so this is our L. So if L is less than 1, it will converge. So converges when x plus 2 absolute is less than 1. What does that mean now? Remember again, how do you simplify or how do you rewrite the absolute value inequality? So you will say negative 1 is less than x plus 2. Now I have removed the bars, and that's what we are trying to do. We are trying to get rid of these bars, because you cannot say from here just that x plus 2 is less than 1. That is not enough. That is not the whole answer. So you have to have the proper way to do that, and that is that we write it like this. Now remember, we want to find out with the values for x, so I will subtract this 2 from all the places. So we end up getting negative 3 is less than x is less than negative 1. Okay, so what is the interval? Well, we are not going to call it interval of convergence, but our interval is negative 3 to negative 1. This is the interval we got from the ratio test. So now what are the endpoints? So endpoints are negative 3 and negative 1. So now we check the convergence on these points individually. So let's say check or when x is equal to negative 3. So when x is equal to negative 3, what does the series become? Remember, we saw in a previous example, by plugging in the values, we get different series. So that's what we are going to do. We are going to plug in negative 3 for x. So this is our series. And you can see when I plug in negative 3 here, what am I going to get? Negative 1 raised to n. Okay. So we have summation. So we already have in the series negative 1 raised to the power n plus 1. And we have at the bottom n squared. And over here we have x minus plus 2 whole to the n. But x is negative 3. So this gives me so negative 1 raised to n plus 1, and then this part is going to give me negative 1 raised to n. Now these two bases are same and the powers will be added. So I end up getting negative 1 raised to the power 2n plus 1. And then now negative 1 raised to the power 2n can be thought as negative 1 raised to the power 2 whole raised to the power n. Because remember, when you have a power on a power, the powers get multiplied. So we have now, so basically now what happens is negative 1 square is 1. So we have 1 to the n. So which means we have 1. Remember this, that whenever you have negative 1 and you are raising it to an even power, you'll get a 1. And this is an even power. This is an expression which kind of which we use for even numbers. So if someone says, can you give me formula for even number, that is 2n or 2k or 2j or whatever. So 2 times a number is always going to be an even number, so that our series reduces to summation n is equal to 0 to infinity negative 1 to the power 1 over n square, which you can think of as negative 1. We can pull it outside, and then we have summation n is equal to 0 to infinity 1 over n squared. Okay, now we have to talk about the convergence or divergence of this series. So what will you say? Well, this is, what is this? This is a P series with P equals 2, which is greater than 1, therefore converges. What converges? The original series. Sorry, this series converges basically. Or you can say this. Okay, so it means the series converges when x is equal to negative 3. We now check the other endpoint, which is negative 1. So when I plug in negative 1, this already we have. Now we had an x plus 2. So negative 1 plus 2 will be just a 1. So which is equal to summation negative 1 raised to n plus 1 over n square. Now notice that the previous case that we have dealt with, now that is just the absolute quantity of this current series. So if you notice this one, this is the absolute of this. So because, so we can say, since summation 1 over n square n is equal to 0 to infinity converges. So I could also have said it like this. Let's say, since this, which is equal to absolute of negative 1 over n square. So I'm taking this actually this negative 1 inside. Since this converges, so summation converges by absolute convergence test. So we now see converges at negative 3 and converges at negative 1. Therefore, first let's write the interval of convergence is, so we had the negative 3, negative 1, remember? But now we will include the endpoints, because we saw that the series converges at both endpoints. And how do you find the radius now? Now we could have written over here, from here, we can see that the radius is 1, or from here, so radius is 1. But if you forgot to pick up from there, you can easily get it from here. What do? You find the length of the interval. So this is negative 3, and there will be a negative 2 here, and then a negative 1. So we are talking from negative 3 to negative 1. So this is the middle point, and this is your R. So R is 1. Radius of convergence is 1.